Hi there, welcome to my channel. In this video, I'm going to discuss about the solution to add two binary strings. Let's look at the problem description. We are given two binary strings A and B and we have to return their sum as a binary string. Let's take a look at the example 1. So the first binary string is 1 1 and the second one is just 1. So the output is 1 0 0. This is when we convert this into a decimal, this value is 3 and this is 1. So 3 plus 1, 4. The binary representation of 4 is 1 0 0. And for the example 2, the first string is 1 0 1 0, second is 1 0 1 1. And the expected output is 1 0 1 0 1. So when we add these two numbers, we get a carryover. So that gets added as the most significant bit here. That's why this string length is 5. Constraints for this problem are the length of the binary string is ranging from 1 to 10,000 and both the strings contains only 0 and 1 character, and each string does not contain a leading 0 except for the 0 itself. So if we see here, there is no 0 prefixed. Let's look at the approach to solve this problem. We are given these two input binary strings, which is 1 1 1 and the second one is 1 1. So the expected output is 1 0 1 0. Decimal value is 7, decimal value is 3, and this is the decimal value is 10. Okay. So when we do binary arithmetic, we start adding the bits from the least significant bit. Okay, so we start from the end of this binary string. Okay, we keep adding the bits present in the corresponding index in each iteration. Each addition will result in a carryover also. If, for example, in this case 1 plus 1 is the sum is 0 and the carry is 1. So next we have 1 plus 1 plus 1. Okay, so in that case the sum will be 1 and the carry is 1. And when we add that carry to this bit, it will become the sum will be 0 and the carry is 1. So 1 0 1 0. Okay, basically we have to do the addition starting from the least significant bit until we process all the bits in the smaller string. For example, in this case, the smaller string is B, which has only 2 bits, but the longer string is 3. So we have to add the bits present in both the strings only for 2 iterations. Then in the last iteration, we have to just simply keep adding the carry, that is from this part of the binary strings addition. Okay. Then finally, if there is a carry, then we have to add it as the most significant bit in that array. And before that, the output, we need to allocate space for the output. Okay, so if you look at it, the output, the number of bits in the output is 4, which is 1 plus the length of the longer string. Okay, so always we have to allocate a space for the output string, which is equal to 1 plus the length of the longer string. Okay, so that's what I have written here. So first we initialize the longer and shorter variable with the length of the longer and shorter string, and then we allocate a space for the output, and then we initialize the count variable with the length of smaller string so that we only do that many number of bit additions. So perform the binary addition count number of times on the bits from the end of the strings. Then once that count number of bits is processed, then remaining bits in the longer string will be added to bit 0 each time along with the carryover. Let's look at the flowchart. Input for this procedure is a binary strings A and B, and first we initialize the A len and B len variable and longer and shorter variables, and then the output array. Okay, so the A len contains the length of the first string and B len contains the length of the second string, and also the longer variable contains the length of the longest string, and the shorter variable contains the length of the shortest string. Okay, then we initialize the sum and carry, and then the count variable, and then the index I and j. So the count is initialized to the length of a shorter string's length, and the index is I is set to longer -1 and the index j is set to shorter minus. Then we start performing the additions, count number of times in this for loop, starting from the least significant bit. Okay. So in each iteration we call the addition procedure with the bit value present in the longer string at the current index I and the shorter string at the index j, and also along with the carry. Okay, so we call the addition procedure. Basically that will do a bit additions and then it will return the sum and the carry for that operation. Okay, so the return value is assigned to the variable sum and then carry. Next, the computed sum will be added to the output list at index I plus 1. The reason why it is I plus 1 is we allocated extra 1 bit for the carry that will result in this addition operation at the end. Then we decrement the index I and j. So basically we move towards the most significant bit. So once the count number of bits addition is performed, then we come out of this first loop. Then the remaining bits in the longer string should be added with the carryover repeatedly. That's what this for loop is performing. So we check whether the index I is greater than or equal to 0. If so, we proceed and call the addition procedure with the digit at index I in the longer string and with the value 0. Okay, so only bit 0 will be added because we already completely processed the shorter string. So we assume that this bit is always 0, and then we pass the carry also, and the return value of that function is assigned to sum and carry variable. And next we assign that sum in the out list at index I plus 1, and then we decrement I. So this will repeat until we process the remaining bits in the longer string. Once that is completed, then we come out of the loop and then we check whether the carry is equal to 0. That means the addition operation did not produce a carry. So in that case we have to exclude the first digit that we allocated for the carry. The rest of the out array will be converted into a string and then that string will be returned. If there is a carryover resulted in the addition operation, then that will be set at index 0. That will be the most significant bit in the output string. So that is set at index 0 and the final string will be converted into string and that string will be returned. Let's look at the flowchart for the addition operation. So input for this procedure is bit x and bit y and then the input carry. There are 3 cases. Okay, both the bits are 0. That is one case. In that case, the sum and output carry will be 0. Okay, and the second case is if both the bits are 1, x is also 1 and y is also 1. In that case, when we add those 2 bits, we get 0 as the sum and also we get the carry. So that will be set to the out carry variable. If either one of them is 1, then in that case the sum will be 1 and the output carry will be 0. Okay, so if you carefully look at it, we did not include the in carry in this addition operation. We just compute the sum and the carry for only the bits x and y. Next we add input carry. So if the input carry is equal to 1, only then we have to do this processing. If it is 0, then we don't have to update the so far computed sum and the carry. So we just simply return the sum and output carry. Okay, but in case if the input carry is 1, then there are 2 cases. One is if the computed sum so far is equal to 1. In that case, the sum value will be altered. because 1 plus 1, the sum will become 0 and the out carry will be set to 1. So if the sum is 0, in that case we just have to only update the sum to 1. Then finally we return the sum and out carry. Let's move on to coding. First I define the constant for bits 1 and 0. Next I initialize the variable a len with the length of the input string a and b len with the length of input string b. Then I initialize the variable longer with the length of longer string and then initialize the shorter variable with the length of the shorter string. Then I allocate the space for output list. This allocates space for the carry also. So the output string length is the longer string length plus 1. Next I initialize the index I, which points to the least significant bit in the input string a. So the longer minus 1 is set with I, and j is initialized with the value shorter minus 1 that points to least significant bit in the input string. Then I initialize the sum and carry variable. Initial carry is set with bit 0. Then I initialize the count variable with the value shorter. So basically we process only the count number of bits that is equal to the length of shorter string. Next I write the for loop that performs count number of bit additions. And here I check which string is a longer string. Depending on that I pass the appropriate bit value in the corresponding string. So in this case the input string a is longer, so I use the index I for the longer string and j for the shorter string. Otherwise I switch the index. So in this case I use index j for the input string a and index I for input string b, and then I have passed the carry, and the return value of this function is assigned to sum and carry variable. In each iteration I assign the sum at index I plus 1 in the output array, and then I decrement the index I and decrement the index j. So we move towards the most significant bit in each iteration. Next I write the second for loop to process the remaining bits in the longer string. Here I, based on the a len and b len value, I decide which one is the longer string and pass the bit at index I in that string, and then the second operand will be 0 because we already processed the shorter string. So I pass 0 as the second operand and also the carry. If b is longer, then I read the value at index I in b string and pass that to addition function, and the second parameter is 0 because we processed the shorter string already, and we pass the carry flag also. Each iteration the sum will be assigned at index I plus 1 in the output array. After the remaining bits processed, then I check whether there is a carry. If the carry is 0, we have to exclude the first element in the out array and convert the remaining into a string and return it. Otherwise, set the carry value at index 0 in the out array, and finally convert that out array into a string and return it. Next I am going to write the addition function. So it takes 3 arguments, one is x, y and in carry, all are of type byte, and it returns sum and out carry variable. They are also of type byte. So if both the bits are 0, x and y is 0, then the sum and out carry will be 0. So I assign sum with 0 and out carry to 0. Else if both are 1, in that case we have sum is 0 and the carry is 1. If either one of them is 0, then the sum will be 1 and the carry will be 0. Next, we have to add the in carry with the sum. So if the in carry is 1, then I check whether the previously computed sum is 1. If so, we have to update the sum to 0. And set the carry to 1, out carry to 1. Okay. If the sum is 0, then we have to update the sum to 1. And finally return the sum and out carry. Next I am going to run the test cases. Compilation error 37. Okay, the typo. Okay, all the tests passed. Next I am going to submit this program. Cool, this program is accepted. Next I am going to do the code walkthrough with sample input. Let's do the code walkthrough for this input. The first binary string is 111, the decimal value is 7, and the second binary string is 11, decimal value is 3. 7 plus 3 10. So the binary representation of 10 is 1010. First we initialize the a len and b len variable with the length of input string a and b. So a len is 3, b len is 2. Then we initialize longer variable with the length of longer string and shorter variable with the length of shorter string. So longer is 3 and shorter is 2. And next we initialize the out byte slice with the length longer plus 1, because the addition operation may result in carry, so we need space to store that carry, so that's why we allocate extra 1 bit. Then we initialize the index I to longer minus 1, so I will be set to 2 and j will be set to 2 minus 1 is 1. Then we initialize the carry and sum both to 0, and the count variable is initialized with the length of shorter string, so the count is equal to 2. Then we enter the first for loop which performs count number of iterations. So in each iteration it adds the bit from the least significant bit. So in this case, when we enter the outer loop iteration 0, I is 2 and j is 1, so these two bits will be added. Okay, so initially the sum is 0 and carry is 0 and the count is 2. So when we leave this iteration, the thumb is 0, 1 plus 1, 0, and there is a carry. So the carry is set to 1. And in the iteration 1, I is 1 and j is 0. We add these two bits and the result is 1 because we have the carry 1. So in addition to adding these two bits, we also have to add the carry. So that's why we get 1, and that addition operation result in carry 1. So sum is 1 and carry is 1. And we update the count. So now the count is 0. So this we break out of this loop. And then we enter the second loop to process the remaining elements in remaining bits in the longer string. So in this case there is only one bit yet to be processed. So this loop takes care of performing the addition. So in the iteration 0, I is equal to 0 and sum is 1 and the carry is 1. Okay, and we have to add this bit with 0. So that's why we pass the bit in the longer string and the bit 0 and the carry resulted in the previous computation, which is 1, and this is 1. So 1 plus 1, 0 is the sum and carry. So that carry is, if you look at this condition, so if the carry is 0, we just ignore the most significant bit, but in this case there is a carry. So what we do is we assign the carry at index 0. So the carry is assigned here. Then the final string will be, the final array will be converted into a string and that will be returned, and that is an expected output. Next I'm going to do the time and space complexity analysis for this solution. Let's do the time complexity analysis for this input. So we have the input string A with length 3 and B with length 2. Okay, and if you look at it, we call the addition function in each iteration, okay, to perform the bit additions. Okay, let's see how many times this function is called in both the loops. Okay. So if you look at it, this loop runs the length of the shorter string and this loop runs longer string length minus the shorter times. So this runs for this input, first loop runs 2 times the length of the shorter string, and then the second loop runs only once. So totally 3 times the addition function is called. Basically that is equal to the length of the longer binary string. Okay, so the time complexity is order of n, where n is the number of bits in the longer string. So that is 3. That is the length of this input string. So with respect to the space complexity, it is order of 1 because we are not allocating any additional space to store intermediate data. For example, we allocate space only for the output data. So we can exclude this in the space complexity analysis. So the space complexity is order of 1. Thanks for watching this video. Have a great day.